right. So I'm going to talk today about Know Your Data, lessons learned. It's exactly 2 years after I gave this kind of talk on the AI Week conference, also here in Tel Aviv University. It was a big AI Week conference just before the COVID started. And 2 years later, there are new stuff that I want to share with you. And I've simplified it a little bit, but please stop me and ask me questions once you find something interesting. So a little bit about myself. My name is Gershon Celniker. I started my data science career in 2013 when it was just the beginning of data science as a profession. And it happened when I was working in Wiser. Wiser, it was an e-commerce startup, Israeli startup based in San Francisco. And the investors and the CEO, back then I was algorithm developer, they told me, it happened in a day, you're not an algorithm developer anymore, you're a chief data scientist. So that's it, I switched to data science back then. And we started to work with, and actually I was, because my academic background is bioinformatics, biology and computer science, I was mainly coding in R. Even though here I was a tutor, I was teaching in Tel Aviv University Python, but I was still coding in R. And then once I started to work in the industry, I moved to Python, Spark, and all the distributed environments and technology. These days I'm working as a research group manager at General Motors, and I will give you a little bit introduction about what is General Motors here in Israel. So first of all, what we're going to talk about, GM, dirty data and ML bias, top down from like really high level examples all the way to the data. Some test-driven data science tips. A hands-on session will be a little bit limited, but based on your interest. And I will show you a package called Octopus ML that I hope that you will use and contribute. Okay, so General Motors in Israel. How many, by the way, familiar with General Motors in Israel? Heard about it? Okay. What are they doing in General Motors in Israel? Are we making cars? What is the what's happening in the Israeli center? No. Okay, so we work on these 3 zeros: 0 crashes, 0 emissions, and 0 congestions. So 0 crashes is the ultra cruise, the autonomous vehicle. So we work on autonomous vehicle that it's better that humans will not drive. They will rest. They will read the newspaper. They will WhatsApp to other people. They will learn on Coursera courses, whatever, not drive. It's better for us that they won't drive. 0 emissions is the electrical vehicles, and 0 congestions. Once we will have a connected cars, we will be able to control the traffic. And by the way, if you can sleep during the trip and you can read and stuff like that, so the traffic might not be such a big pain in the ass. This ultra cruise, it's the autonomous. It's like the autopilot of Tesla. It's done here in Israel, Canada, and Ireland. We just went to press with this. We worked on that already for 2 years, and it just went to press recently. So we're going to cover 25% of the road in the United States, and it will be a level 2. So it's not totally autopilot. You still need to pay attention to the road, but yeah. 95% of the roads in the United States, sorry, 99% of the time that you drive. So you're 5% of the roads we won't be able to take. Like for now, instance, roundabouts are hard. It's a hard task for an autonomous car to do. The Zoom people are interrupting us. Okay, so now 2 short videos, and then we will start with the Know Your Data, how data is important for ML. By the way, how long are you already in the course? Like you're towards the end, the middle, really in the beginning? Oh, wow. Okay, so many of the things here might be a little bit of, so maybe some of the things will be here a little bit not familiar, but give it with a break, it will be fine afterwards. Okay, the sound is a problem, huh? So in this video, we can see the electrical vehicle, we can see the connected cars and the autonomous autonomous driving with this green light on the wheel, on the steering wheel.
Because it is Wi-Fi enabled, VIP can receive software updates over the air, which is constantly evolving and adapting, making sure our customers always have the latest technology. Eventually, it will connect to other cars, traffic lights, and the transport infrastructure around it. Opens up a new world of possibilities. And to ensure that connection is safe, VIP's DNA includes additional cybersecurity protective features, ever evolving to guard against potential risks. Best of all, VIP will appear in over 29 global GM models by 2023, giving more drivers access to personalized choreographed lighting and driving experiences, no matter which GM vehicle they choose. Pretty intelligent when you think about it.
Okay. So the Israel Center, as I mentioned, it's 600 people right now, mainly engineers, data scientists, researchers. It started from a very small R&D, research and development center that consisted of 30 people for a long time, and then it grew up very extensively. And now we're going to recruit another around 200 people by the end, the next coming year. And we moved to a big, the former Microsoft building, the 6th floor building. So we're growing fast. All right. Now, the sound here is terrible. So I hope that, and also you only. רגע. זאת אומרת, פה ב... I can do different speaker.
No. Wait.
Okay, so the guys didn't hear on the sound as well. Okay, so now it's good that they will hear. Okay, so there's how many of you are familiar with Anaconda from Continuum? I think that's the name of the company. Yeah, so they have a big conference, and for the conferences, what they're doing, they have a very funny movies. And this one, it's called Perception. And it talks about issues with models, production, and funny stuff. All right, so that's the movie of Perception. It will be 2 minutes, and then
there's one thing you should know about me. I specialize in machine learning, a very special type of machine learning.
You're talking about deep learning.
So what's the most powerful thing in the business world? Capital? Intellectual property? No. A deployed deep learning model.
This model's not accurate enough. We need to go deeper.
Models work with test data in the sandbox, but it's only when we try to integrate the real data on the production cluster that we realized something is not right. Think about it. How did we get here?
Well, I started fitting the model.
Did you spend 2 weeks cleaning it? Did you have to pay a vendor to hydrate it? Did you have to blackmail a VP to run a VLOOKUP?
You're right. This must be test data. We're in the sandbox? Why don't all the data scientists try to escape?
In the sandbox, your data is clean. You have a GPU all to yourself, and your model accuracy is perfect. It's easier to just let yourself be deceived. It's called Perception.
Why are they shooting at us?
They're the IT team. We won't let our Python models out of the sandbox. Why don't we write everything in Java?
Model's too accurate. The data is real, but is this a real cluster?
All our tools are here. Anaconda's installed. Everything just works. It's too perfect.
We're still in the sandbox. We have to get to the production cluster.
What is that?
That's GDPR, but we don't have to worry about that until next month.
If I do this, I get to go home.
Because we're trapped in a dream world within a dream world?
No, because my son has a soccer game at 6 and I need to get a jump on traffic.
GPUs available.
Hold on. It looks like the IT guys are using them to mine Bitcoin?
No, Dogecoin. Bitcoin mining uses too much energy and contributes to global warming. And Bitcoin has really become a settlement layer and not a currency. Dogecoin is a...
Shut up! Enough with all the stupid coins and cryptocurrency hype.
You're gonna overfit.
Some interesting stuff here. Did you have 2 weeks to clean the data? Overfitting, sandbox, test data, which is perfect. Yeah. Okay, so we'll start with GIGO, garbage in, garbage out. Okay, and the ML biases examples. So in this example, there is it's Uber car, autonomous vehicle, and it drives in I think in Boston. Let's see where it drives. I think in Boston, yeah. And what happened? This car it drove over 6 red lights, and the reason is because the perception algorithm wasn't good enough to detect the robots, the stoplights, and they had a different database of the road, where are the robots, where are the red lights located, and it wasn't updated. So it just crossed the red lights without any issues. So that's a data issue. This is Yosemite. You see, this is an interesting road. What do you think? It's a regular. It's some kind of an anomaly, no? So there is the road, which is really narrow. Suddenly, it's like 2 lanes going separate ways. And Tesla, they didn't have it in their, I think they didn't have it in the training set. So this is what happened. It just continued straight. So this is kind of issues that, so this is, when I said 95%, that's the 5% that doesn't work. So you need to be, the driver need to be attentive. So that's an issue. Yeah, it's actually, I will, if you have time, I will show there is the autonomous, the auto summon, that you can summon your vehicle. It's around 400 meters, something like that, from a car parking, and there's no driver. So what happened if the car makes a violation? And it happened many times, and I can show you a video of that. Right now, the policemen, they don't give fine to anyone, but they can give the fine to the owner of the car because he's responsible in the end. But it's a tricky one. There's no policy yet. It's a tricky one. This is an old one, but it's about a Palestinian guy that says good morning, and the translation got it livgoa b'hem, and you can see the context livgoa b'hem plus livgoa b'hem, and you can see the truck, what do you call it? Not the truck, the tractor. So that's dangerous. When someone, so he was arrested, but all he wanted to say is good morning. So there's biases as well in the Google translation. This is an old example. So you can see the skyscrapers, airplanes, cars, and gorillas. And she's not a gorilla. And then this guy is like, Google Photos, you fucked up. My friend is not a gorilla. And then he checked it. He took lots of photos of him and her. And he's like, it's only photos that I have with her doing this. Without her, it's fine. So that's an issue. You know, by the way, how Google solved this issue? Yeah, this is what they done. They just removed the gorilla label, and that's it. How can they fix it? Like the proper way, not not the quick and dirty way. To detect you as good. Here's an example. You can see sheep. So that's amazing. You can see a photo and it gives you tags, mountains, grass, and sheep. And then you can take the same photo on the same algorithm without the sheep. And what will happen? You still see the sheep. So just, yeah, it's an issue with the algorithm. It just learned that the grass, if there is grass, there has to be a sheep. And for certain areas, it's the right thing, but maybe not here in Israel. So I have a question for you. What happens if there is a bias? Okay, there's an expected value and the true value, and there is a bias. What happens if you have more data? Am I going to solve the bias? What do you think? If it's consistent, I will have more data. I have like 1 terabyte of data. I will have 5 terabytes of data. It will be still biased. It will be very accurate, wrong answers still. Yeah, we need to solve the bias. Not the amount of data is not the only thing. Okay, now we'll start the data failures, and then we will talk about ML failures. And some of these failures, and I will give you an approximation what happened. They cost lots of money. So I worked in Wiser, and then I worked in a company called Verint, a big corporate here in Israel. I moved to Checkpoint, and then to a small startup named Clue, and now I'm in General Motors. So this is my lesson learned from the places I led the data science and research teams. So what happened here? We have an evaluation of the model. So we deployed the model into production. By the way, we're right now in Checkpoint building, and it was a Checkpoint. We deployed the model in production, and we had an amazing result. And we were so happy, and we celebrated, and we continue monitoring the results for a long time. And we were, in a way, maybe a little bit naive, but it was perfect. It wasn't perfect 100%. We still had some issues. The F1 was around 95%, something like that. So we thought that everything is good until one time we detected, we saw that many files, and you can see it here, they have exactly the same name. They have exactly the same name, even though, and they're coming from the same client. Something is wrong here. You can see the dates, the file name, the same client. What's happening over here? What's going on? And then we realized that there is our files, our own files that we're familiar with. Other engineers, they testing the system. So, and it's like 20% of the files that we get, and we know the right answers because we know these files. So our results are biased because they are better than reality. So this is the green line. That's what we thought our model is. And in the end, it was like the blue line here. So the performance was still good, the production rate, but wasn't the best that we thought. So we were in a la la land for like 6 months. And it's just because, and we found out because we monitor the data, is not only the performance of the model, you need to monitor the data. And we saw that because thank goodness the name was the same, something like that, so we could detect that. So when someone want to check their QA team, they want to check their programs, so they send the same files over and over again. Yeah. So it was one of the testings. Yeah. Here's another issue. We have a meta classifier that takes input from many other. You familiar with meta classifier or not? Not at all. Okay, I should have come in like 6 months' time. Then it will be. So meta classifier is a classifier that takes inputs from other classifiers, and it's the final one that gives the final decision. So one of the other models which give me the feature, what happened? They changed the name. They put a V2 for the feature name. They just put in different name, and we didn't receive this feature for a long time. And you can see it here. Suddenly, we didn't receive this feature. Then we received it a little bit. So this is a package called missing info, and it gives you you can see the features. You can see that one of the features, these features are missing. We don't have the data for them. And thank goodness, one of the employees, they decided to check the data set, and he saw that, wow, something is wrong. Like I should receive, this feature should be miles. So something like driving a car with 3 wheels. It's a big issue. And thank goodness we found it. It was manually found. It wasn't automatically found. Another issue is the outdated. So we have a ground label for our, and also for testing. And it's from the cyber. We have files and PDFs. In order to have the label, sometimes it's like malware.com. Totally, you can see what does the community thinks about it. And in that case, what happened? We didn't update our ground truth. So sometimes a file was suspected as a malicious, but it's not malicious in the end. It's not malware. It's a legit file. Our ground truth, the one that we tested our models, wasn't updated. So it's like eating a hummus from 1 month old or something like that. It's not a good thing to do. And by the way, how we find it, this is a very nice visualization that I like. But we can see here probability from 0 to 1. Okay, and I have another hue, another coloring of negative and positive. So positives are the files that are actually malicious. They're malwares. Okay, and in the negative, I have the files that are benign. It can be a normal PDF file, it can be a payslip, and a CV someone sent, a Chrome installation, whatever. It's files. So they're all benign. So what is the best model? The perfect model. What will happen? How this distribution will look on a perfect model? 1 and 1, yeah. All the positives are in 1 and all the negatives. So this model is actually not bad. It's high F1, it's not bad. But we see that something is happening here. We have malicious files and they're receiving 0 probability. The model thinks that they're totally benign. So what's happening there? This is weird. So this is how we detected this issue, because it usually doesn't happen. You get some kind of probability for a malicious file. And also you have the same thing here. You see benign files that we suspect it's false positive, that we suspect that they are malicious. So by examining these, I don't interesting about the middle. I'm interested about these very far examples that are that need to be taken care of. And all the time, every iteration of a new model, we usually check these corners here, and it gives us the most. And usually the data issues, the data leakage, and stuff like that, it's here. So this plot, it helped us a lot in that case. Okay, data leakage. So data leakage, we had another issue. So there's duplication, and it happens a lot. Almost in every company I work, we have a problem with duplications. And by the way, when you go to interviews and they give you a home assignment, many of the companies, at least all the companies that I worked with, you will get this kind of test. They will give you a data set that it's dirty, that you need to clean it. And most likely it will have duplicates. And when you have duplicates and you do a cross-validation, or you split it to test and train, like here, test and train, you will see instances in training and you will see the same instances in test. And you will think that the model is perfect, the model is very good, and the F1 will be high and stuff like that. And then you will need to submit your test file, and the one that you don't have the label for, and it will be very bad results. And you won't understand what's happening. And then you will see that it's just a duplicate file. So the duplication, it's a big issue. There are many types of data leakage. One of the famous one, how many of you are familiar with Kaggle? Okay, so there was a competition in Kaggle, and it was about the breast cancer. So it was mammographs. It was images. Some of them were malicious, some of them were benign. And there were lots of metadata. What hospital it was taken, what resolution, what time, and stuff like that. And so, this metadata, I wouldn't be using it for my model, but some guy used it for his model and put it all in deep learning. And there was one thing, there was a timestamp. So there was a timestamp, and what happened, in order to, the guys that did I think it was Google, I don't remember who initiated this competition. The guy that initiated this competition, what he did, he put the malicious, the positive examples. He put the time. He didn't have the timestamp, the real one, so he put the timestamp 1 a.m. in the morning or something like that. He put it on the on a clean hour, like 1, 2, 3, not 3:45.63 seconds, 13 seconds, something like that. And the model, it was an artifact. It's an example of data leakage. The model, the deep learning model, it managed to find that artifact. So his model was almost perfect, and he got first place. And he got the money for it, by the way. Yeah. So it was their issue. So, but it was an artifact, and the other guys that didn't have any chance against that. So this is actually very recent. And it's an issue. So this is a pipeline of how you prepare the data to train the model. By the way, did you already train the model or not yet? Not yet. Wow. Okay. So when you train the model, you need the XY matrix. The XY matrix is the features and the label. So in this case, is a hospital who is going to deteriorate in intensive care unit and who is not. That's the goal of this model. So we're doing mapping of the patient's data, heart rate, blood pressure, intensive, non-intensive blood pressure, blood saturation, lots of features, all the blood tests and all the other tests that the patient had, around 80 measurements we generate lots of, we remove outliers. Outliers, for instance, if someone has a heart rate of 400, it can be, or heart rate of 0, it's dead already. So this kind of heart, or blood pressure of 1,000, it can't. So there's lots of artifacts in the data and in the devices that that measure that. And then we're doing other features, temporal and derived features, and we're doing labeling. So we know who is deteriorated in past. We trained this model on the data of, I think, 6 years of intensive care unit patients, thousands of them. We knew based on the notes of the doctors what happened to the patient and what time he deteriorated. So we have a label. We knew we want to predict if he's going to deteriorate or not. And we had a label that he deteriorated in a specific hour. And what happened to us, we deployed the model, we trained the model, and the performance was a bit problematic. And we had a problem with the mapping. So we did a lot of work, like around 3 months work for the FDA submission. It's a medical device, it's a support decision device, and we had to receive the FDA for that. It's a heavy regulation, especially on AI products, which they're not familiar with. It's easier to I don't know if it's easier, but in a way it's more FDA approves medical devices and vaccines and stuff like that. It's something that they did many years ago. To authorize an AI product, it was a bit hard for them. It was new for us and for them as well. So what happened to us after all this work, we decided to do some more tests before filing it to the FDA, and we saw that we have a problem with the mapping. This problem with the mapping, that means that you need to do everything again. All the models that you trained, the analysis that you did, it's not good. You have to repeat everything again. It was a 3 months work of 7 people. For a small startup of 40 people, that's a lot of money. That's millions of dollars. That's a lot of money. And we also, we missed the FDA submission date, so we had to wait another 6 months. It was horrible. And then when we did it the second time, we had a problem with labeling. And the problem with labeling was that sometimes some people, they intubated. When they put them on hemodynamic support, their heart rate is very low. They give them medications to increase the heart rate. It's a deterioration. But sometimes the patient didn't really deteriorate. He was scheduled a procedure that they wanted him to be more stable for the procedure. Or someone, his shift is ending at 6, and he's afraid. And before that, just in case, stuff like that. It happens a lot. So we had a problem with the label, and we had to go to clean it. And it was another issue that that we found only after effect. So here, what I can say, it's trust by verify. You have to verify everything. And to make sure, especially things in the beginning, that if you find an issue afterwards, it will set you back big time. Okay. Okay, that's another example. During the automatic, so it's again about the label of the integration events. What we saw, we received this model. It doesn't, you don't know what cross-validation is, right? No. Okay. I think you should watch it again once you once you fitted some models. Cross-validation, it's very interesting. I will just explain what it is. So I'm training on this fold. I have a data. This is my data, 100% of the data. If I split it for 20% and let's say 80%, I will train only on 80% of the data. That's number one. And I will test it only on this fractional data. But maybe most of my patients are here. Most of the events are here. Maybe it's not stratified. Maybe it's not uniformly distributed. So what it's usually, there's a method that many use, k-fold. In this case, it's 5 folds, 1, 2, 3, 4, 5. What we're doing, we're training the model 5 times. And each time we're testing on a different part of the data. And what we expect to have the same performance. And here we should look at the F1 positive, because this is the class that we're interested in, who is deteriorated and who is not. And you can see it's not what we want to have, a robust, stable model. It's something that it's very constant, that we can see that the results are constant, and there's no riddle. There's not much variance in that. And here you can see this model is amazing. when we tested it on this data. And once we tested it on the first fold, it's horrible. There's almost 100% increase in performance. What's happened? Something is wrong here. And then we realized that we have this better labeling issue. So we tested the model. By the way, if you average it, you will see you will get a great performance, and you can go to the FDA and receive the approval. And the FDA, by the way, didn't ask us to do the K-fold. It was our decision to do that. Once we saw that, we understood that there is an issue, and we fixed the label, and then it was stable. So the K-fold and this kind of plot, it's very important to understand what's happening with our data. By the way, what in the end, eventually what we did, less is more. The physicians work hard to have lots of, to label as much events as they wanted, because there is this assumption that more data, the better the results, right? We wanted thousands and thousands of patients, and because only low number of, thank goodness, of patients are deteriorating, around 5%, we need to have. You don't want to lose the patient that deteriorated. You don't want to lose this label. So they have very complex labeling, automatic pipeline. And at the end, there was a lot of noise. There was a lot of garbage there. There was a lot of iterations that are not true. And then what you're doing, you're trying to train your model based on this very biased and wrong label. And then your model is just not good. It's not stable. It's not good. In real life, in the real scenario, it will be horrible. It will detect someone that is going to go to procedure and not really deteriorating. Okay, that's a very interesting one. Let's see if you understand this. Now I'm back to cybersecurity. So assumptions ahead here. By the way, the guys in the audience from Zoom, if you have any question, please let me know. Okay. Now we're going to ML failures, not a data issue. So, and this is the feature names. Because the feature names are property of the company I worked in, I couldn't show them. So I can show you only this interesting graph. What we can see here, the true positive, we can see a feature. And if he existed, in which kind of files? In true positive cases or in false positive cases. So we can see a feature like this one. Mostly he's in false positives, and this one mostly in false positive, and this one is mostly in false positive. This feature is incredibly good to find the real malwares, right? So what do you think you should do about this feature above, or this one? That the ratio here between the true positive and false positive is so high. What would you do? Huh? You want, so what's happening right now, your model says that it's a positive, that it's a malware, and in reality it's not a malware, and you can see it's because of this feature. This feature goes to the model, and it contributes to very high false positives rate. So what is the assumption? What would you do? You will get rid of it, right? It's a very bad feature. You just get rid of this feature, or reverse it. It's interesting. Okay, we didn't listen to you. We listened to to this guy. So just before, and it's a very smart feature, by the way, just before we decided to get rid of it, I decided to do another test, and it's in feature importance. When you train the ensemble of trees or boosting or bagging, LGBM, cut boost, the one by Yandex or for instance XGBoost, what the effect for which side. You know the feature importance, that the feature is important, but you don't know if it's helping to detect malicious files or the benign. So what I did here is a regression. I did lasso. You can see here the direction. So these features are important for to find the malicious files. And if the feature is high, if the value of the feature is high, and this is the case of that feature, it's actually good to for the negative. So this feature was actually very good, and it contributed and gave the information to the model that this is not there is not a problem with the file. And it's actually a good feature, and we almost removed it. So it gave the information to the model that it's fine. Yeah. So by the way, this feature, so the way we worked in Checkpoint, I had a big team of central team of data scientists, and we worked with many business units. So that was a project from a threat prevention, and one of the business units. We put 4 projects to production, And what happens, sometimes we don't know their features. The whole team of malware analysts and the software developers, they write their own features. Sometimes and the title of this talk is Know Your Data. So we didn't understood, we just see the name of the feature so we can guess what the feature means, but we don't know what was the intention behind this name and what. So when we spoke with the developers, they told us that this is exactly what they did. They tried to have this feature in order to reduce the false positives. And we almost removed it. One of the data scientists just almost removed it. So yeah, that's a lesson to learn. So assumptions, you need to be very, very careful with that. This is one of the interns, actually is now a Checkpoint employee. So there is features, some of them are binary, some of them are continuous, and he decided to do very special. Instead of using one model, he decided to use random forest, extra trees, naive Bayes, and gradient boosting, and no cut boost for some reason. I think he should have, it's not enough, I think he should have had more models. And then you see the logistic regression here. When I spoke about meta classifier, that's a meta classifier. I receive all the inputs from other classifiers, and he's the one that gives the final decision. What do you think about this model? It looks great. By the way, when you ask him, why did you do that? He tells you, look, I have more models. It's every model is better in one aspect. And I have different, like the binary and the continuous. So for instance, for the binary, I will not put it in gradient boosting for some reason. And the continuous, I will put them only in naive Bayes. So there's like, there is some sense to what he done. And this is crazy. Once you will start to train models, you will see that to train such a thing, it's really difficult. First of all, if you train these models, classifier, you can't use the data that you train this model on the meta classifier because then it will be biased. So you're already limiting your data. That's an issue. Second, to train all of them, it's crazy, lots of work. And in that case, it's not needed. So we did a test. We put a single IGBM instead of all these 5 models. What do you think? What happened? Huh? The IGBM worked much better. We did one proper one. We did the hyper tuning, so there are lots of properties to the parameters to the model. So we did the proper one. We trained it, and we did an HPO hyper parameter tuning long time, and we had a really great model instead of this disaster. And by the way, the guy like worked months on that, and it went to garbage. Huh? Yeah, it's very hard to do. It's a disaster. Yeah, and also, by the way, if you think about production, also in production, like you need to deploy 5 models, and then and they're sequential. You need to have the results of all of them, even though they're milliseconds, they're very fast, but still, like it's a complication that it's not needed. And I can see it in many companies, by the way. Sometimes to impress the investors. I don't know. During diligence of companies that want to get sold, I can see that a lot, unfortunately. Many times you don't need this complexity. But by the way, I need to be, some cases are really hard and you do need to have 2 different types. So we need to be very careful here. Some cases are extremely tough and you need to use some kind of pegging or stacking. That wasn't the case in that respect. It's an interesting one by Andrzej Karpati or something, but his name is. So during his PhD, he was doing he was working a little bit about the databases, and most of his time was models and algorithms, and we published papers on that, and that was his most of this work was on that. And the data, the time he spent on data, cleaning the data, analyzing the data, EDA, stuff like that was very minimal. When he moved to Tesla, to the industry, look what happened. Actually, I think it's even less. You work a lot on the data all the time because it's iteration. You train the model, you try to do analysis of false positives, negatives, and then you find big issues, and then you need to fix that, and it takes a lot of time. So during my career, I think working on data, it's much more, and it's also periods. Once your data is robust and stable, then you suddenly work a whole month on different models and try different stuff. But the majority of time is working on the data in the industry, in the real world. Okay. So challenges in data modeling: data provenance. Where is the data collected from? Data versioning. Can I trust it? Remember that we had one. We lost a feature because someone changed the name and no one checked it, or we had a feature that someone else developed and I didn't understand what it's actually doing. Data quality. There's no data free. There's no data error free. You need to always check what's happening there. Data bias. Some biases it's hard to fix. Some biases are very difficult, but you need to reflect on that. Model bias. As well as problematic. So what is my proposal is to do more data crunching and more test-driven methodology, and we will talk about it soon, and less fit predict and less stacked models. So stacked models is what we saw with lots of models, and fit predict, it's something that people have to do. They work on data, it's hard, and sometimes to get to the details of the data, it consumes lots of time. And what happened to us, by the way, with look, I manage this project. I manage this project, and it costs us big time, especially for a small startup. When you're in a big corporate, it's something that the time is different. When you're a small startup, time is money. And you have competition, and you need to make sure you can not only that you provide value to the clients, and in this case is people in the intensive care unit, you want to have the best product you can. But even data and product fucked up, okay? Big time. Not only me, my whole team. We were 8 people and we all fucked up over there. What happened? And what happened, I call it technical debt. We had the companies exist 5 years, it's Clue. And there were many people working on the mapping, and the mapping is a very people work for that for years, like to map the exact feature from the EMR in the hospital. It's tough, and there's lots of issues, and they want to take this mission because we were under pressure to deliver. We were under pressure to deliver. We wanted to receive the FDA approval so we can sell our software. We were under pressure. And when you rush, this is what happens sometimes. We didn't have time to do tests. We didn't have time to go over it. We wanted to get a product right away, and this is the crucial part. Just decided to hope that. And what happened, because it's a startup, and every year people are leaving, and the knowledge didn't stay with the rest of the people. That's funny. There was significant issues there. And we had to put and to fix it. It took us a month. And labeling here, you trust the physician that did the fancy label, but then when you see the false positive, things doesn't add up. See someone that is totally fine. There's no reason to intubate him, no reason whatsoever to intubate him, and he's intubated. And then you see that there's a problem, and you have to, and the label was wrong. And the less is more. You should have clean data than a rusty bad one. Yeah. So even after all that, because of time pressure and because of the quick and dirty, we paid the price by delaying the project almost 9 months. By the way, in the end, we received the FDA approval. We received the emergency one and also the long-term one, 510K, and it's now working. Hopefully for you won't go there to the intensive care unit. It works right now in Sheba and Ichilov hospitals, and also several hospitals in the United States. So we monitor the patients there, and we fix the issues, so it's safe. Don't worry. But you should. It was our software was used widely, and we have the design partner, so they use the software, the algorithm, even before we have the approval partner. About that, okay. Unit test. So, how many of you are coming from a background of developers? No? Yeah. So you know what unit test is, right? Unit test is very important. When you write a feature, usually what is data science? You have data. You clean it, you pre-process it, and then you write features. So you extract the features from the data, you train a model, and you validate and monitor you validate the performance, and you deploy the model in production and monitor in production. If you are a deep learning guy, then you don't write so much features. The net is extracting the features for you. But sanity tests are extremely important. So my rule of thumb is every feature deserves a sanity test. For every data transformation, I want a sanity test. I want to make sure that it works. And sanity test. Unit test. Sanity test is it's the obvious stuff. It's like you try to test someone that is totally fine, like a patient, and it should receive a low probability. And someone who is in bad position. So this is a sanity test. And data integrity afterwards is also very important to make sure what I told you about. I'll give you an example of a blood pressure. It should be around 80 to 120, but it can be, we received from several patients a metric of suddenly a measurement of 1,000 and something. What happened? So when you come and visit the intensive care units, you see that the patient is lying on his bed, but sometimes the nurse comes and she switched something. And she moved him, and she pressed pressed his hand near the device that checks the invasive blood pressure. So, and then suddenly you get these artifacts, but the artifacts, and they're unfortunately they affect the model. So what you need to do, the integrity test, you need to remove these outliers. It's very important to pre-process them. Yeah. But sometimes I understand that the blood pressure shouldn't be 1,000. And by the way, I don't need to be a physician. I can do it. I can have a histogram and the distribution of the data, and I can see that 1,000 or something like that. It's it's a big file, more than 2 standard deviation. I can remove it. But sometimes, and this is the problem, I'm in the imbalanced data set. Do you already started to get attention to balance and imbalanced data set? Yeah, I will give you an example. And machine learning, you don't know what is recall precision? No? You do? Okay, recall precision. Okay, so that's important. So let's say include example, only 5% of the patients are deteriorating. So if my model, the FDA approved model, will say that everyone is fine, what is going to be my accuracy? I'm amazing. My accuracy is 95%. I'm always, but it's a great metric. But what is the value of this model? 0. It doesn't help me. The physician wants to know from the people that are from the positive, the one that are going to deteriorate, how many of them I actually get 0. So the precision recall is 0. The precision is how wrongly I predicted. So maybe how wrongly positive I predicted people. So for instance, the FDA approved model, we detect 60% of the patients that are deteriorating. So 40% we can't detect them. They are, in the end, the medicine is so personalized and there are so many aspects and there's so much data that is missing. We can't predict 40% of the deteriorations. They happened without we didn't have them in the data set. We can't. We have only around 60%. But our precision is 10. So what does it mean our precision is 10? So for every patient that we detect that he's going to deteriorate, 9 are false positive alerts, and that's a problem. But it still contributes and it's still beneficial. But it gives the effect of alert fatigue. The doctor seems that like when I give an alert that someone is going to deteriorate, you need to take it seriously. And if it's only right 10% of the time and it's applied only for 60, that's a problem. But it's still, this is the best we have. And and the FDA approved it that it's beneficial and it's widely used, but there is more, it's a very challenging problem and there's much more to learn from that. Yeah. There is a package that I have, it's called Octopus ML. I put it in GitHub, it's free of charge, and it's I forgot the licenses that you can do whatever you want. You can take it, you can modify it, you can have credit, do whatever you want. You can contribute back, like Andrea, one of my employees, contribute back. And it's a tool that does EDA and data validation and detection of artifacts and feature examinations. And I will show you some examples of what it does. So I took the bike sharing. It's a Kaggle competition. I will show you some other tools, and then we'll talk about Octopus. So I really like this one. It's called Data Frame Summary. It's like describe of pandas, but it's much better because it gives you the unique values, shows you the missing and the missing percentage, and also give you the type. So it's a little bit more to the regular describe. I use it very often, and it's very nice. The missing value analysis, that you can see what's happening here. Like you can see here that the cheat feature or mass, and this is the feature that I made actually, or the casual here. We see here from many observations, we're missing data. What's happening over here? It's very nice tool to detect artifacts and issues. So I really like this visualization. Pandas profiling, it's very cute. My tool in a way is a competitor to Pandas profiling, but you can see here that this data set, it has 189 duplicate rows. So it gives me this warning, and that's an important one. So once you have a test, a home assignment, use the Pandas profiling or my tool, and it will give you and also it can give you that the feature is highly correlated with another feature, or this one has a lot of missing values. So this is my tool. I have the same thing, in some ways a little bit better. So for instance, the duplicates, I give you the percentage and I can show you them. I also check artifacts, and maybe Kostya will invite me again, and I will show you how I'm detecting the artifacts, or the left or the skewed distributions, or some features that are totally constant. That's a bullshit feature that you should remove. And the data leakage. The feature importance, data anomalies, dataset comparison. This is a nice one. How many of you, I don't know if you did actually, Titanic, did you train and test on Titanic? Yeah, okay. So the test and the train in Titanic is interesting. It's very different distributions. And I have what I did here, I trained a model that the purpose of the model is distinguish between the train and the test. That's the whole thing. You need to distinguish between the train and the test. And by the way, the model is not so bad. The F1 was like 65. The population is so different that it's different. So what happened? They cut the number of passengers by there was a list, not randomly, not stratified or something like that. So the differences are huge. The differences are in fare, in age. There are more old people in the test, in siblings, and the P class, but mostly in the fare and age. There was a significant difference. I use this tool to compare data sets. And by the way, if you're doing Kaggle competitions, use it. It's very interesting to see what's happening, because many times there are differences in test and train. Once you know that, you can engineer another feature in order to mitigate that. Okay, thank you guys. If you have any questions, I'm here for you. Yeah. Okay, so that's interesting. I will show you here. You can see my screen, right? So Octopus, I started to work on that. It's like lots of tools that I used, and I started to work on it as my personal project. So I worked on that during the time that I worked in all the companies. So it's belong, and I didn't want it to be bound to a company, or that I wanted it to be open source. So it's totally open source. Anyone can use it, and it's not belong to anyone. Yeah, you can do that. I have now an employee who is doing games. Okay, and it's incredible. And I had a team leader that was writing a book. So everyone can do stuff that it's not, but not in competition. Like here, there's a tool. It's an open source tool. They can't see the screen. Oh, sorry. Okay. Okay, so this is the Octopus package. It's a handy tool for data science, and for you right now, very early. But once you will start training fit and predict models, please give it a chance. So what I showed you, for instance, the K-fold, the K-fold visualization, ROC, and this is the prediction distribution. So I have it all here, and it's very straightforward, and it has lots of data. So the data set comparison, the data all there. And one of my employees, we needed something for Clue that was proprietary for Clue, and she contributed to that. So we solved it there. So yeah, it's a one, and it's involving. Like I'm doing it usually on weekends and time that I have time to do work on that, but On Kaggle, by the way, on several Kaggle, and you can see it on Titanic, stuff like that. I also used it, and it's a nice one. And people, I'm going to release soon a feature, especially for Kaggle, that will help to win competitions. So if you want to start with competitions, you should give it a try. Guys from Zoom, anyone has question? Remark? No? Here? Yeah. Yeah. So that's mine. This is my package. So I want to work with more people. So far, I've worked only with Andrea, but it's a small one. But when I was working in Checkpoint, we had a problem with LightGBM, and before that, in Variant, we had a problem with XGBoost. We wanted to have our own weight function. So what happened in the Variant? What we did, we took the open source package, we modified it, and we used it. But we didn't contribute back because it was it was time consuming. It was very long to do that. And we decided not to do it. We used it and we wanted to contribute back, but we didn't do it. And with FlightGBM, for instance, there were lots of problems. Wow. It's a very robust and nice model, and we had lots of problems, and we did contribute back. So I think it's very important. You use something, and there are plenty of tools, like really great one. Now, by the way, I'm using for model explainability. There are LE5, Sharp, there are many packages. I use widely Sharp package, and I'm going to contribute back. So we fixed something over there, and we added another feature, and it started from an issue. You have an issue, and if there is an interest from the maintainer of that package, it gets back to you. So we're going to, so yeah, I'm very in favor of that. There's a saying called sharing is caring. So yeah, you should care about other people as well. And it's good. Yeah, I think I can give one example of open source, and it's from Variant. So the Variant company is, there are two, now they separated two different companies, but we worked a lot about speech, on speech recognition. And we had a very expensive IBM solution, very expensive one. And there were 12 people working on that solution, around 12 people. And then one of the team members, team leaders of that research group that worked on speech, he decided to do a POC with something new, an open source called Kaldi. I don't know if anyone heard about Kaldi. Kaldi is an open source for speech recognition based on deep learning. And it has lots of advantages over the legacy old ones. And he decided to give it a try. Okay. And guess what happened? It was much, much better than the proprietary, than the solution that cost lots of money. And the reason is that on IBM, maybe a couple of hundreds people worked on that, and then it was maintained by people at Variant, 12 people. Kaldi is thousands of people contributing, and it's based on a new technology, and they just moved to Kaldi. And many other companies, it's open source, you can use it. It's incredible. You can see a product that didn't exist 5 years ago, and you had to go to the big giants and pay lots of money, and now you have a perfect solution. You don't need anyone for that. So even, what's his unit? Even you can have this Kaldi and train, I don't know what language train for, or specific domain, and it will work. It will work as if you have a team of hundreds of people working for you, and it's totally free of charge. So yeah, it's amazing. All right, thank you guys. Have a great day.